All right, this is quiz C. If I scroll down, you can see it's quiz C for Unit 2. And I want to simplify this expression. So as I'm looking at this, what I noticed is that there is a factor of sine of x in both terms of the numerator. So my first step is going to be to factor that out, sine of x, and what I'm left with is secant squared of x minus 9. In the denominator, I actually have the same thing. So I'm similarly going to factor it out. GCF. I don't have to label these steps, but I can. And I'm left with secant of x plus 3. Okay. Well, these make 1. Now I have secant squared of x minus 9 over secant of x plus 3. And I'm thinking, how are these things related? This one's squared, but that one's not. That is also a perfect square, but that one's not. But they're related. This is that squared, and this is that squared. So if I call this a plus b, and I call this a squared minus b squared, hopefully I recognize the difference of squares. And I can factor this into secant of x plus 3 times secant of x minus 3. That's a plus b times a minus b. Then the bottom is just secant of x plus 3, and that's the only factor. Like, there's another factor of 1 there, right? But it goes away. That whole factor makes 1. This is worth 1 now. Okay, so the whole thing equals the secant of x minus 3, and that seems about as simple as it's going to get. Single trig function, single operation. Yeah, that's it. It's done. So this must be fully simplified. Verify that the equation is an identity. Okay. So I'm going to do the thing where I draw the line and I don't cross it. The left-hand side looks way more complicated than the right-hand, so I'm going to start here. I'm going to start messing with this. The cosine of theta, I don't know what to do with that. But the tangent, maybe I can use the reciprocal identity for secant and the quotient identity for tangent. So this becomes sine of theta over cosine of theta plus 1 over cosine of theta. Oh, common denominator, I like it. So I'm going to go ahead and simplify. I have the cosine of theta over sine of theta plus 1 over the cosine of theta, the common denominator. I added the numerators over the common denominator of cosine. That does not become cosine squared. I'm not multiplying anything. Nothing gets multiplied here. I am adding. So adding fractions over a common denominator just means add the numerators and the denominator stays what it is. Now I'm going to multiply by a very specific one that is cosine theta over cosine theta, because this cosine theta will make a 1 here instead of there. I've introduced the 1 so that I can cancel the denominator in the denominator. Great. So now I have cosine squared theta over sine theta plus 1. Where am I going? I'm trying to get 1 minus sine theta. These seem to be related in that they're kind of conjugates, but this is organized wrong. I'm going to reorganize this too. I'm going to make this 1 plus sine theta so that I can really think of it as 1 minus as conjugates, right? Okay. Ooh, but cosine squared, this is just simplify again. Cosine squared is 1 minus sine squared. Oh, there's my difference of squares again. Nothing here is cancelable, but this is factorable. I can factor this as 1 minus sine theta times 1 plus sine theta, all over 1 plus sine theta. I'm choosing to put the denominator in parentheses to show that it is its own factor, and it will make a 1 just like that. This is worth 1. 1 plus sine theta over 1 plus sine theta is 1. And now I have 1 minus sine theta, which is what I was hoping would equal 1 minus sine theta. Ta-da! Kind of feel like saying ta-da sometimes when I'm done. Oh, I haven't finished labeling. So to go from here to here, I use the Pythagorean identity. And then I factored, and then I simplified. Yay, done, verified, established. Now, use an addition or subtraction formula. Okay, good thing I still have my formula sheet from the last video. To find the exact value in simplest form, rationalize if needed. Okay. That is not a number on my unit circle. I don't know that one, and I would need a calculator to find it unless I had a sum or difference formula. So that means I need to write cosine of 7 pi over 12 in terms of a plus or minus b. How do I write 7 pi over 12 as a sum or difference of two other numbers? Well, 7 pi over 12 is right here, just a little more than pi over 2, right? So I might be able to use these acute numbers. Well, if I break up the 7 into 3 pi over 12s plus 4 pi over 12s, well, that's just pi over 4, and that's just pi over 3. So I can rewrite this, instead of cosine of 7 pi over 12, I can write it as cosine of pi over 4, 45, plus pi over 3, 60. This is the same as 115 degrees, I think. Whatever 45 plus 60 is, 105 degrees, sorry. It's 15 degrees past 90. Okay, bonus, yay. I'm able to do that. Now I have to use the formula. So I'm looking for the cosine sum. It's on the left of the paper, and it says the cosine of pi over 4 times the cosine of pi over 3 minus the sine of pi over 4 times the sine of pi over 3. Great. Now each of these has a value that I know from my unit circle. The cosine of pi over 4 is square root of 2 over 2. These are all acute angles in quadrant 1. They've all got positive values, so my sines work out nicely as far as that is concerned. The cosine of pi over 3, okay, pi over 3 is here. Cosine is 1/2. The sine of pi over 4, square root of 2 over 2. And the sine of pi over 3, the sine is the bigger number, square root of 3 over 2. Great. Look at how my denominators work out so nicely. I get the square root of 2 over 4 minus the square root of 6 over 4. Yay, common denominator. Square root of 2 minus the square root of 6 over 4. That's it. That's as much as I can combine it. That is simple as it gets. That is that number. This one's a lot easier to plug in to check my work, because I know that should equal exactly the cosine of 7 pi over 12. So I'm in radian mode on my calculator, so I'm just going to type it in. Cosine of 7 pi divided by 12 is negative 0.258819-ish, is about, right? Well, parenthesis square root of 2 minus square root of 6 end parenthesis divided by 4 is negative 0.258819. Look at that. They're the same. Matchy matchy. Hooray. And I like my answer. Now you might say there is technically a GCF here, but if I rewrote that as square root of 2 times 1 minus square root of 3, I don't think that's any simpler. So I still like this answer. Okay, as far as fully simplified. Hooray, that was quiz 2 for unit 2.